So kule video le ngifuna sicheck ama reactions lawa enzeka inside water if ufaka acid or if ufaka base, right? So example number 1. So kahle kahle la kule ma reactions si combine ama theory A2, which is Arrhenius theory and Bronsted-Lowry theory. So for example, okay, ngizocala nge-acid, example 1. So example 1, we have HCl, hydrochloric acid. So already siyazi ukuthi the hydrochloric acid, it is an acid, right? But the acid siyifaka emanzini. So according to Arrhenius, it is a substance that ionizes in water. So that is why siyifaka la emanzini, right? All right, so according to Bronsted-Lowry, okay, we do know that this is a strong acid, so it means the forward reaction is favored more compared to the reverse reaction, which is fine. And then according to Bronsted-Lowry, an acid is a proton donor. So this is the acid, right? So we classify this as an acid, right? So it means the second substance, le reactor na le acid, that will become your base, right? So si classify the substance yokuqala sathi, okay, this is an acid, so automatically the second one should be a base. And what is a base? According to Bronsted-Lowry, a base is a proton acceptor and an acid is a proton donor. So it means the acid is a donator this hydrogen ion, right? So when I donated this hydrogen ion, kusala Cl minus, right? Lab. Okay, so and then what will happen? The hydrogen is on la, and then we have H3O plus. Okay, so the products, we have the hydrogen is formula H3O plus, and then la paksala Cl minus, right? So as identify a base na acid on the right hand side, siyazi ukuthi H3O plus, definitely that is an acid, because acid vele classifier ngalama hydronium ions. So it means automatically the second one should be a base, right? So now reaction yokuqala la esiyenzile using hydrochloric acid siyifake emanzini, right? Okay, so second example, we have second example, so sebenzisa i-base, right? So la ku-base sizofaka ammonia, which is a weak base, so it means the reverse reaction will be highly favored. Siyifake emanzini, H2O, right? And an acid is a proton donor, a base a proton acceptor. So according to classification yethu siyazi ukuthi this is a base, so it means this will become the acid automatically, and then an acid will donate this hydrogen ion, and the acid lena donate ngale kuzosala OH minus because hydrogen A1 isukile, right? But then ngale will have NH4 because at an A1 la, and then that will be NH4 plus. So the products, we have NH4 plus, and then if this is a hydrogen A1 la kuzosala OH minus, right? So nasiyangal on the right hand side, sifuna classify whether which one is the acid and which one is the base, and siyazi ukuthi this is definitely the base, the hydroxide ion is the base, so this one will become the acid. Right, so these are two examples so far, but ngifuna sinote something la. Now check reaction yokuqala, the first reaction. If you look at the first reaction, or the example 1 reaction, we have water classified as a base, but in the second example we have water classified as an acid. So now it means this substance can act as either a base in the first reaction or an acid in the second reaction. So that substance, we call it an ampholyte. We call it an ampholyte. So it means water can act as a base, or it can act as an acid. So that is an ampholyte. So what is an ampholyte? It is a substance that can act as a base or an acid. It can act either as a base or an acid. So that is an ampholyte. So it's important to be able to identify the ampholyte. If ubheka reactions I2, just check whether in the first reaction is it a base or an acid, and check in the second reaction whether it is an acid or a base, right? Okay, so that is another important definition, an ampholyte. Okay, let's go to another example of an acid. Let's say we have sulfuric acid. Example number 3, sulfuric acid, H2SO4. But what do we know? What information do we know about sulfuric acid? The first thing about sulfuric acid is that it is a strong acid, right? It means the forward reaction will be favored, will be highly favored. It is a strong acid. It ionizes completely in water. And the second thing that we know about sulfuric acid is that it is diprotic. So if it is diprotic, it can be able to donate 2 hydrogen ions, right? But when it donates the 2 hydrogen ions, it does not donate at the same time, or donate 2 at the same time. It donates in 2 stages. So there is the first reaction where it donates 1 of the hydrogen ions, and there is another reaction where it donates the last hydrogen ion, or the second hydrogen ion, right? So it means this will have 2 reactions. So the first reaction, sulfuric acid reactor namanzi, right? And okay, by identifying these 2, it means this is an acid and this is a base, and an acid is a proton donor. So this will donate 1 it will donate 1 hydrogen ion, right? So if it donates 1 hydrogen ion, it means izobana 1 less hydrogen la. Okay, and then le, it is the base, and the base a proton acceptor, so it will have 1 more hydrogen ion, right? So lagu kuma products will have H3O plus, which is the product esithola through the acception of this hydrogen ion, right? And then plus the second product, nasusa eli 1 lap, we have 1 less hydrogen, so it will be HSO4, but minus because it's a hydrogen eli 1, right? So this is the first reaction. So donate proton local, this is the first proton, right? And for the second equation, isn't that kusaseleli 1 la hydrogen ekumele donate? So for the second reaction, you take that second reaction, uthatha H SO4 minus, right? Still is emanzini, right? So an acid, this is an acid because here examine donate hangish. So that is an acid, then it means this will be a base, right? Okay, so look, identify upon the first reaction. We have an acid, we have a base, and then this, obviously this is an acid, therefore this will be the base in that case, right? But uyayithatha le uyiletha la ngaphansi uyireacta namanzi, it becomes the acid. So there must be a term for this HSO4 minus, right? It can act as a base in the first reaction, but in the second reaction it acts as a what? As an acid. So that is an ampholyte. All right, fine. So this will donate one hydrogen ion and we'll get H3O plus for this one, and let's SO4 2 minus because mine says lose 2 yama hydrogen ions, right? And by classification, this is an acid, this is a base, so just donate away 2 lama hydrogen ions, right? So maybe question number 1, which one is the ampholyte? Identify the ampholyte. We are checking lapha phezulu. Okay, water lana is a base, nangapha is a base, so in this case it is not the ampholyte, right? It is an acid, right? But then HSO4, sorry, HSO4 minus base lapha phezulu, but in this case laphansi it becomes an acid, so this is an ampholyte. This is our ampholyte, right? So HSO4 minus, that is the ampholyte. So what is an ampholyte? It is a substance that can act either as a base or as an acid. All right, so from these reactions, right, from these reactions in aqueous solutions of the acid and base, we can identify what we call conjugate pairs. The conjugate pairs. All right, so what is a conjugate pair? Or what is a conjugate acid and a base? A conjugate pair, we have an acid and a base, so this is a pair, right? So lama pairs law, they differ by a proton or they differ by a hydrogen ion, right? So we can say these are compounds that differ by a proton, and the proton is the hydrogen ion, right? So the simplest way of identifying this is that if you have an acid, for example HCl, right? So if this is an acid and you want the conjugate base, you want the conjugate base for this acid, you just subtract one hydrogen, né? So if we remove one hydrogen, then Cl minus or Cl up. So this is the acid, this is the conjugate base of that acid, right? And what about H2SO4? If you want the conjugate base, you subtract one hydrogen ion, so that will be SO4 minus. So this is the conjugate base, right? So if you want the acid, if you have an acid and you want the conjugate base of that acid, you want the conjugate base of the acid, subtract or remove one hydrogen proton. Right, simple. Remove one hydrogen proton. Okay, for another example, let's say we have H3PO4. This is an acid. What is the conjugate base? Subtract one hydrogen, that would be H2SO4 minus. Right, every time you subtract a proton, you remove a positive, so there is a negative that arises. Okay, and then the conjugate base of CH3COOH, right? So this acid, this is the acid you want the conjugate base, you remove one hydrogen, so that will be CH3COO minus. So that is the conjugate base. Okay, so what if you have the base and you want the conjugate acid? You add one hydrogen ion, right? Because they only differ by one hydrogen ion. Okay, so let's say you have a base NH3. You want the conjugate acid for this one. This is the base, the conjugate acid, then it would be NH3 because you add one proton, NH3 plus, right? And then, okay, let's say water is acting as a base. So for the conjugate acid, you add one hydrogen ion. So this is the basic method of determining the conjugate pairs. If you have an acid, you want the base, subtract a proton. But if you have a base, you want the acid, add a proton. But what about from these reactions? La reactions la so conjugate. You just label them. This is an acid. Okay, let me use a different color. Hydrochloric acid is an acid, right? So it means the second, which is H2O, it means this is a base, right? And this is an acid, that is a base. So if ufuna ukuthola ama-pairs, you take the acid and the base on the right hand side. You take the base and the acid on the right hand side. So I'm a conjugate pairs. In this case, we have HCl and Cl minus. You have the acid, you want the base, subtract one hydrogen to Cl minus. Right? You have the base, you want the conjugate acid. What do? You have the base, you want the acid, you add one hydrogen. So that is the conjugate pair. And then for the second one, you have a base, you choose the acid that side. You have an acid, you choose the base that side. So that is the conjugate pairs. You have the acid, you choose the base that side. You have the base, you choose the acid. This is the conjugate pair. So if a question says write down a conjugate pair, you say H2O and H3O plus. Another one, H2SO4 and HSO4 minus. Conjugate pair, acid and the base, base and the acid. Right, so this is how we determine the conjugate pairs. But if they give you an acid randomly, they say H3PO4, for example, this is the acid. They say find the conjugate base. If you want to find the conjugate base, you subtract one hydrogen. So this is the conjugate base. So that is how you find conjugate pairs.